Hello everyone, today we will discuss dose response relationships and other very important terms in pharmacodynamics. So basically as the concentration of drug increases, its pharmacological effect also will gradually increase until all the receptors are occupied and the maximum effect has been reached. And a very important properties of drug, which is the potency of the drug and the efficacy of the drug, can be determined by this graded dose response curve. So potency can be defined as the concentration of the drug that produces 50% of the maximal effect. And the parameter that is used to determine this potency is called EC50. While efficacy is how much of the drug response can be produced when the drug interacts with the receptor, and this efficacy is dependent on the number of drug receptor complex that has been formed and the intrinsic activity of the drug. Intrinsic activity is the ability of the drug to activate the receptor and cause a cellular response, and this activation can be full or partial, which we will be discussing it later. And an important parameter here is the Emax, which is the maximal efficacy a drug can reach. So drugs can be categorized according to their intrinsic activity as full agonists, partial agonists, inverse agonist, and competitive antagonist, or irreversible antagonist. So when we say agonist, we mean like the drugs mimic the action of the original endogenous ligand for the receptor. Like the drugs, they will produce the same effect like which the endogenous ligand will be producing. And endogenous ligand are the ligands which are already produced from our body. So if we start with the full agonist, when the drug binds to the receptor, it will produce a maximal biological response because the drug will be stabilizing the receptor in this active state. And they said they have an intrinsic activity of 1. While partial agonists, they activate the receptor, but from their name they only have partial efficacy. Like they cannot produce the same Emax as full agonists. So their intrinsic activity is greater than 0 but less than 1. Now the third type is inverse agonists. Inverse agonists, unlike full agonists, they stabilize the inactive receptor form, and also they cause the activated receptor form to convert to the inactive form. So they will be decreasing the number of activated receptor, and they will have intrinsic activity which will be less than 0, and they will also reverse the activity of the receptor and will exert the opposite pharmacological effect of the agonists. While antagonists bind to the receptor with high affinity, but they possess 0 intrinsic activity. That is why they have no effect in the absence of an agonist, but they can increase the effect of the agonist when the agonist is present. So antagonists are divided into 2 or 3 if we count the allosteric antagonist. So the first one is the competitive antagonist. This type, both the antagonist and the agonist bind to the same site of the receptor in a reversible manner. That's why they are said to be competitive. So this competitive antagonist, it prevents the agonist from binding to its receptor and maintains the receptor to its inactive state. But this inhibition can be overcome by increasing the concentration of the agonist relative to the antagonist. So this can shift the agonist dose response curve to the right, like the EC50 will be increased without affecting the Emax. The second type is the irreversible antagonist. This type it binds covalently to the active site of the receptor, so it will be reducing the number of the receptors that will be available for the agonist. So this will decrease the Emax, but it will not affect the EC50. So a very important difference between competitive and non-competitive antagonist or irreversible antagonist is that competitive agonist, antagonist, it reduces the agonist potency, like it will increase the EC50, but the irreversible antagonist, it will reduce the agonist efficacy, like it will decrease the Emax, as you said before. So the other non-competitive antagonist is the allosteric antagonist. This type, it also decreases the Emax. It is called an allosteric antagonist because it binds to a different site than the agonist bind inside, and it will prevent the receptor from binding to the agonist. The last type of antagonist is the functional antagonism, which antagonists act at a completely separate receptor, but it can initiate effects that will functionally be opposite to that of the agonist. Thank you for watching. Please don't forget to subscribe to this channel.